Good morning. We did the first half of 2.5 yesterday, and we're going to finish the second half today. And I hope you're enjoying this because I find this is a lot of fun, and most of my students really enjoy it once they get into it because it's not hard. It's just a question of pulling together some skills. And you guys sometimes have lists that you make for yourself, right? Where you've got some jobs to do and then you check things off. It's a little bit that same feeling as you cancel, right? That it's some of that same feeling of satisfaction. Anyway, for me, I might be a weirdo, but some of you may be enjoying it too. 2x squared plus 16x plus 24 divided by 3x squared. So I'm sorry, this is my fraction. I shouldn't say divided by because this whole thing is divided by x plus 6. All right, so what do we do when we divide by x plus 6, which is really x plus 6 over 1? Well, first we reverse. We multiply by the reciprocal. So 2x squared plus 16x plus 24 over 3x squared times 1 over x plus 6. Now we combine the numerators and denominators, and we get 2x squared plus 16x plus 24 over 3x squared times x plus 6. We now have to do our factoring and see what we can take out and see if we can get any reductions. So I'm going to factor out a 2 first and get x squared plus 8x plus 12, and this is still over 3x squared times x plus 6. As I look about what to factor here, there's a lot of factors of 12, but I can see that 6 times 2 will give me an 8x in the middle, so x plus 2, x plus 6, and on the bottom I end up 3x squared and x plus 6 as I had before. And now I can start with my canceling, and I can see that my x plus 6's are going to cancel out. And I get left with 2 times x plus 2 over 3x squared. And my excluded values are 0 and negative 6. Okay. Let's move on to example 6. That's Lou who wants me to throw his ball, but he's gonna have to wait till I finish with your lesson. All right, example 6. So this is advertising. It is a long problem, and I may cut it short slightly, but the important thing is knowing how to set it up. So the amount A in millions of dollars, so amount A in millions of dollars spent on all advertising. So all advertising. And the amount T in millions of dollars, which is just for television advertising in the United States, are given, this is the period 1970 to 2003. I'll just put that here just so we have that amount recorded. Can be modeled by, so they give us 2 equations. A equals 13,000 plus 3,700x over 1 minus 0.015x, 1 minus 0.15x. Oops, I forgot a 0. Let me make sure I write that correctly or we'll be in trouble. And T equals, in other words, just the television advertising, is 1,800 plus 860x over 1 minus 0.016x. And so I hope you understand that television is, there's lots of different advertising, right? There's newspaper, magazine advertising, there's billboards. Television is one subset of that, okay? And these are what the two equations are for. And x is the number of years, right, since 1970, as it often is with these problems. So the question is, write a model that gives percent. So they want to know model that gives percent in decimal form of the amount of TV advertising compared to all advertising. In other words, let's use the model to find out what percentage, what's the percentage of all advertising, which is TV advertising. And then we'll try to find what that number is in terms of millions of dollars. Okay, so percent, right? We know what a percent is. We've done those before. Is going to be the amount of television advertising, right, divided by all advertising. And so we have some models to use to find what that is. So we're dividing the television advertising over the total advertising. What does that look like? That is 1800 plus 860x divided by 1 minus 0.016x divided by 13,000 plus 3,700x over 1 minus 0.015x. Just as we did with the others, they're much bigger numbers, but the process is exactly the same. And all we need to do is multiply by the reciprocal. So we have 1800 plus 860x over 1 minus 0.016x times, and we have on top now 1 minus 0.015x, and on the bottom 13,000 plus 3,700x. And we combine this all in one big fraction where we have 1800 plus 860x times 1 minus 0.015x over 1 minus 0.016x times 13,000 plus 3,700x. Okay, we now have our whole fraction, and we want to figure out, can we do any kind of factoring? Now I'm cheating. I don't know why the book did this, because it is not reasonable to assume that you could figure out a problem like this in your homework and know, well, it is somewhat reasonable, but it would take a lot of trial and error. So here they're saying, how much can you simplify this problem? And it's sort of like a problem we did sooner, which is how much can you simplify your full equation? Well, you can take out 20. And so if you factor out 20 on the numerator, you end up with 90 plus 43x times, and this stays the same, 1 minus 0.015x. And on the bottom, you keep 1 minus 0.016x. You can also factor out 20 from this other binomial. And when you do that, and I'm just going to factor out that 20, and when you do that, 13,000 divided by 20 is 650, and 3,700 divided by 20 gives us 185x. these 20s can now cancel here and here. And so you're left with this equation, 90 plus 43x times 1 minus 0.015x over 1 minus 0.016x times 650 plus 185x. And this, if you remember, we've gone through all this. It's easy to forget what we were doing in the first place. We're just trying to find the percent in decimal form of TV advertising compared to all advertising. That's what all this was about. And so we now have an equation that's usable, and they ask us to approximate the percent spent in 2003. Well, 2003, if you subtract 2003 minus 1970, you end up with x equals 33. And so when you substitute x equals 33 into this equation, and I'm just going to put here that this is from 2003 minus 1970, and put into equation, you'll get a percentage, which is 0.239, and they said in decimal form, which means that about 24% of all advertising was TV advertising. Okay, so that's a little bit of a sense of what it would look like in the homework. And I know it was a long problem, but at least you have an idea of what's involved. The math involved is pretty simple. At this point, it's really making sure that you keep track of each step and go slow and steady. But the actual concept behind the problem is not difficult. All right, I'll stop here. This is the end of 2.5, and I will pick up with 2.6 tomorrow.